Okay, so let's continue from where we left off yesterday. I gave an assignment. How far with it?
So the assignment are in my DM, but then the number is just about 20 people who have submitted.
Okay, just about 20 people who attempted it.
Yeah.
Okay, that's fine.
Yeah.
So, as a
I've
quick
wanted
refresher, I would want us to remind ourselves quickly and then we can build on whatever knowledge we have so far. Alright, so yesterday, the last thing we talked about was data types. Yes, we did talk about data types. So we saw that you could have a data that is in a string data. You can have a string data. You can have a boolean data. You can have an integer data, and so on and so forth. We also saw how to display the value of a variable, and then how to assign values to variables, and so on and so forth. A moment. Yeah, me and the right. Right. All right. Let's continue. So, what is happening in the message section? After compiling, I realized that you need to bring what is it an apostrophe before the cout before it can compile and run successfully. Evidence. I don't know what you're talking about. I'm not really even getting your question. Okay. You said you have a question. Hold on. Let me finish with the recap that I'm doing. When I'm done, you can come again with your question. All right. So we saw how to declare variable, how to assign values to a variable. We also said that we have what we call the assignment operator, and that is which allows us to assign the values that we have on our right side to the variables that we have on our left side here. And then we also saw how to declare, or let's say declare and assign multiple um, variables at the same time. So we saw something like so, where we have int um, age, comma score, and then equals to, then we give them this values respectively. We also went ahead to touch on the fact that these variables and then data types we have at the top here, they are not the only ones. We can have other ones as well. There are even more data types, but these are the primitive data types that we have. These are the primitive data types that we have. When I say primitive, these are the basic what data types that we have. All right. So we also saw how to add variables together. So in a case where we have, let's say, first number, which is of the data type or the type integer, having the value 10, and then second number having the value 16. When you want to add these two, you can pretty much say that cout, then you do something like so. Where is hello? Hello? Hello. He's not available. That is how come he couldn't prompt me that I've not shared my screen. I thought this while I had shared my screen. Yes. So let's continue. So that is that. Today, what are we looking at? What are we looking at? We are going to build on the knowledge we've acquired so far. We're going to build on the knowledge we've acquired so far. So we are going to talk about identifiers. A moment, okay? This is the fifth day, right? Okay, so when we started on I think Friday. So Saturday, Sunday, Monday, Tuesday. So Friday, Saturday, Sunday, Monday, Tuesday. So today is our fifth day. Okay. So I want us to talk about what we call identifiers. I believe you can see my screen. Great, 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 great. So when we say identifiers, these are basically um, the unique names that we give to what certain information or data within our program. So all C++ variables must be identified with unique names. And these unique names are called identifiers. So these are unique names given to what variables. So identifiers are basically what unique names given to what variables. So identifiers can be short names like x. So you can have x to be a variable name. You can have, let's say, y. You can have z, and you can have even a more descriptive. So let me do it like so. Or a more descriptive names such as you can talk about, let's say, age. You can talk about name, or let's say even full name. You can talk about what status, etc., etc. Now it is recommended that you use the more descriptive names in order to create understandable and maintainable codes. If you have a variable called x, Later, maybe you might come back to the codes and you don't know what X is actually meaning or what it means, right? But then when you give a more descriptive name like age, when you see age, you know, okay, you are trying to talk about age here. So it is always advisable that you use the more descriptive identifiers. Make sense? Okay, so let's continue. So let me just do notes. It is advisable, or it is recommended to stick with a more descriptive approach of creating identifiers. So to bracket variables or constants. It will get there. Let me use a multi-line comment here. Okay. I hope you understand what is going on. Alright, so let's continue. So let's look at example. So let's say we have a variable called int that we can say um, minutes per hour. Then we say this is 60. So in every minute we have what 60. In every hour we have what 60 minutes, right? So minutes per hour. Now this is actually a good what identifier. You can also do something like so, and it says 60, and this is okay, but not easy to understand what actually what is. I hope you are good. Yes, so we are basically talking about variables, technically identifiers, and how you can what create them, the appropriate ways that you need to adopt to be able to create what acceptable or good identifiers of variables, and that is what we are looking at. So I said example is what minutes per hour. Immediately you see this, you know that, oh, okay, it is talking about minutes per hour. But in this case too, you are saying minutes per hour, but you know it can be sometimes difficult to understand. So a more descriptive identifier like so is preferred. Is that okay? All right. Now let's look at some general rules that you need to follow. When you are naming or creating identifiers, we would want to say that names can contain letters, digits, and underscores. Also, names must begin with a letter or an underscore. We can also say that names are case sensitive, right? So when we have a variable say like my var and my var are different variables or identifiers, we can also say that names cannot contain white spaces or special characters like exclamation, the pound symbol, the modulo, and then some other ones as well. Okay, now the last one, reserved words like C plus plus keywords. Okay, like C plus plus keywords such as int, float, double, what again, boolean, bool. So let me put these ones. Cannot be used as what? Names. These are general rules that you need to pay attention to. Now, what we mean by the fact that names can contain letters, digits, and underscore. So let me go with the first one here. A name that contains letters, digits, and underscore. So I have a variable called full name, right? So I can do full name like so, and then maybe full name 1, and this is actually valid. Are we following? So the fact is that you can use an underscore which is preceding it and then a number, but then you cannot begin with a number. You cannot begin with a number. So that is the second point here. Names must begin with a letter or an underscore. If I do 1 like so, the system is going to give an error. So it is advisable that you begin with an underscore or just letters, and then probably you can have something like so, full underscore name like so. Okay, now we are also saying that names are case sensitive. We are saying that names are case sensitive. My var and then my var are different variables. So in a situation where we have string and I say full name like so, this and this are not the same. Understood? Yeah, so this is what we mean by what it is case sensitive. Even when I go ahead and do this, this is also what different from the first two. So variables are very case sensitive. So you can't declare variable like so and then later you say C out, then you say full name. This is going to give an error because the system doesn't know this, it only knows this. Or you could say that underscore is there, but because this is capital F, you are going to get an issue. Can I continue? All right. Now we are also saying that names must not contain white spaces. What do we mean by that? Names must not contain white spaces. So, or special characters, right? So when you have, let's say, int, okay, int, then we say exam score. This is not accepted. Hello, this is not accepted. You don't have to leave this white space. So the space in between the exam and then the score, that is what we call the white space. You have, you don't have to leave that white space. Your program is going to run into an issue. So what you do is, if you want to leave a space, you can use an underscore to separate it like so, or you can have it closed together. I mean the words close to each other like so. Or if this is going to be difficult for you to read, you can make what, the S of the score to be capital letter so that it will be easy to read like that. And all these things are actually conventions that you need to follow. They are best practices and acceptable ways of what, doing things in a computer programming field. So you have to learn it. You have to learn it. Now, it is also saying that, so yeah, I'll say not not allowed. We don't have to say we have int, let's say grade point, then you add, let's say, a hashtag to it like so. It is not allowed, it is not acceptable. Or you begin with, let's say, an exclamation sign like so. It is not allowed. Or with the modulo symbol or the percentage symbol. This is also not allowed. It is incorrect. Okay. All right. So these are few notable things that you need to bear in mind. Another is for you not to use what we call reserved words. So I can't say int again. I can't do this. So now say equal to maybe 90. This is not accepted because the int is a keyword. It's a reserved word within the programming language C++. So you can't use it. You can't use it. Does it make sense? All right. Reserved words cannot be used as what, identifiers. So that is that. So those are few things that you need to pay attention to. Up until now, I hope we all understand what is going on. Okay. So let's talk about the next thing, which is what, constants. When we say something is constant, what does it mean? Let me get your opinion on this. So, Ansu Eric, you say you can see my screen. Is it still the same? Is it still the case? Okay, so if you can see my screen, you should cross check your network. If your colleagues are not complaining, it means they are seeing it. So if you are not seeing it, it means that your network is not all that stable. All right, so some people are giving suggestions that when we say constant, it means what? Unchanging. Okay, something that does not change, a value that doesn't change. So that is actually what true. Okay, so let's see something. In what cases do you think that in a program we would want to have certain information that do not change? At what circumstances or instances do you think that in our computer program we would have certain information that do not change? Any example? Welcome address. Welcome address. You think welcome address cannot change? Date of birth. Yes, date of birth does not change. Yes, it doesn't change. But when you define it as a constant and then later probably the person made a mistake and wants to update it, what happens? What happens? Minutes per hour. Okay. Yes. So it is constant that in every hour there is 60 minutes. That is true. Number of days in a week. We have 7 days in a week and that can be defined as a constant. That is true. Great. Okay. Date of admission. Yes, that is true. The date you were admitted into a particular institution would be constant. It has not. It is not supposed to change because that can be used for what administrative purposes, for writing reports and all that. Math formulas are also what constant. Yes. Example of a math formula. So y equals what mx plus c. So finding the gradient of a line. Okay, that is fine. Area of a cycle, that is fine. Peter Moore, area of a cycle, what is the formula? Oh, I shouldn't disturb you. Yes, almighty formula is also there. Yes, pi is also there. Great. Pi 0.14. Right. Just saying, or v is equal to what? Where r means what and I means what and then v means what? Please elaborate. Okay, okay, okay. Ohm's law. That is fine. Voltage, where I is current and R is resistance and V is voltage. Yo, me pacho mate. So let's get practical. Let me touch on what constant is. So we've understood constants from a high level, right? So we are saying that these are data or information that we define in our program, and they hardly change. Their values hardly change. So we've cited example that we can define a constant like pi in our program, and then we assign a value to it. And it means that when we do that, we cannot reassign. So let's look at the example. So where we have pi, so pi is actually what? What data type is pi? What data type is pi? Integer? Are you sure? Come back again. Character? I'm sorry. I'm not saying pi as in like the characters pi. No. I'm talking about the value of pi, which is what? The figures. Yes. So you can use double to achieve that. Great, because double allows you to implement what decimal numbers, or you can use float as well. Are we cool? Do you understand? Great. So we say const, then we say double. Now we can say pi. Then we can say 3.14 2 3 like that. Is my machine frozen? Okay. Okay. Can you see my screen? All right. So this is what an example of what a constant. So you begin with a keyword const before the data type and then your variable name or your constant name. Is it clear? All right. So am I doing any printouts here? Okay. So let's try to output what the double variable or constant is holding. So we say C out. Now say value of pi is, then I'll go ahead and compile this and run it. Okay, so I think we should have an output. Oh no, it's not this. I'm not looking for this. Ah, this is what I'm looking for. So I believe you can see what is on the screen. Yeah, so the value of pi is 3.1423 like that. And that is actually coming from the constants that we defined here. A constant that we defined here. Let's look at something. If I should go down and I'll say pi should now be equal to 34.23, and then we run the code. Look at something. Let me compile and run again. You realize what happened? Yes, so it means that you can't reassign a value to the constant pi. You can't do that. You can't do that. So when you are building, for instance, a calculator app, and then some of these scientific um, values and symbols, and let's say values basically, you'd have to use constant to define them. Yes, you have to use constant to define them. So let's say when you want to find the, so when we say pi r square, you have the pi, the radius, like that. So you have to define pi to be constant. So you only take the radius and then you find the exponent of that. Alright. So that is that. Get rid of this. And then comment this one too out. Then we can continue. Now, what again can we talk about? What again can we talk about? I'm going to wipe the screen here. I don't know if I should share this notes with you on the group. So should I share this snippet of notes with you on the group? Should I do that? Okay, so I'm just copying it like that and then cut it, and I'll just dump it in the group. So I have done that, shared this with you in the group. So let's look at few practical examples and then we call it a day and then we continue some other time. So I'm going to declare some few variables. Okay, so I would have int say students ID, and I'll say this student ID is actually 1. Student's age, let's use 23. Float, student fee 70, let's say 90.45. We can also say character, student's grade, this person had a B, like that. Now you realize that me declaring all these variables, I'm being consistent with how I am naming them. So the first part of the name is actually in small letters. The rest are what? Either capital letters throughout. In the case of the ID, it is what? Capital letters throughout, because I means something and D also means something. That is why both of them are capital. But the subsequent ones, it's only the first letter of the second word is capital. So the first word is small letters, and then the second word is beginning with a capital letter, and this helps you to really organize your code and your statement in such a way that it will be easy to read. So adopt this convention, adopt this practice. It is going to help you. All right. Now I've declared and then assigned these few values to these variables here. If we want to print all these ones, we would say print variables. Okay, someone is asking a question. What is it? Why did you see out in a comment? Why did I use see out in a comment? It was I used see out to print something and I commented it out. I didn't want that part of the code to run again. That is why I commented it out. Okay. Another question is, please, why didn't you bring small f in case of what float? Oh, by small f, or your eyes are not good. It's small f, it's not capital F, please. Please, why didn't you bring small f in case of, yeah, so I think I've answered that. I think the fee, where is it? Oh, but I just explained why I'm naming. So these are my identifiers, okay? Student fee, student A, student ID, student grade. These are all identifiers, and I've explained what identifiers are already. They are basically variables, and they are unique names that I've given to all these values. So I'm saying that in creating your unique names or creating your variables, there are acceptable ways of doing it. So I'm saying that I can actually do something like so, but you realize that it will be a bit difficult to read because these are two words. There's one word, there's another word. And if it is combined like so, it is a bit difficult to read. So for you to make it more understanding, there is a better convention that says that okay, the first word should be small letters, or by the second word, the first letter should begin with a capital letter. Have I made sense? Yes, if you don't want to do the capital F thing, you can use what? An underscore and do something like so student underscore fee. Is it clear? Alright. So I think let me just refer it to now the convention that I'm using to name these variables or creating these identifiers, there is a name for it. There is a name for it. So go and find out the various types of um or the various ways of what naming variables. Go and find out. I'm not going to tell you. This has a particular name. When you do student underscore fee 2, this also has a particular name. And then we have one that would have capital S and then capital F, so something like so. And this also has what? This also has a name. Go and find out. I'm not going to touch on that. So student fee. Alright. So we want to print all these variables. So we would basically do something like cout, then we say student ID, right? Then we say student ID. So we can do NL here. Then we say cout student age. Say what is it? Student age, right? The next one is for student fee. Student. Then we also have student grade. So student grade here and L. Then all I'll do is go ahead and what? Run this snippet of code, compile and run it, and let's see what we get. So can you see we are getting all these printouts with the various values? Can you see that? Yes, so that is how we go about that. Okay, great. Now I would want to give you an assignment. Our time is fast spent. The assignment is basically write a simple C++ program that is able to calculate the area of a rectangle. So you have you need to find how we calculate the area of a rectangle, what you need, the information you need to be able to calculate the area of a rectangle. And then when you are done, you see how I printed these things out. You are going to print the various elements. So if it is that you need a breadth, right? You need a breadth. You say the breadth is, then you print the breadth. If you need a height, then you say the height is, or you just say height is, then you print the height. Then the last statement to be the area or area of the rectangle is, then you print the actual area. So you need to find the formula for what? Calculating the area of a rectangle, and then you use that, and then now you print the various elements before you finally print the results, which is what would have the statement area of the rectangle is, then you print the actual area of the rectangle. Have I made myself clear, please? Alright, so go and do that, please. This time around, drop the assignment in the group. So when you are submitting it, when you do it, just copy the code. You see how I'm just copying the code? So you just copy everything like so, with the headers and all these things. Just copy it like so, and then drop it in the group. So when you drop it in the group, make sure you add your name to it. For your full name, don't use any aliases or what have you. Please, I'm not familiar with any aliases. Use your full name, please. Alright, so that is your assignment. If there are no questions, we'll call it a day. If there are questions too, you're welcome. The question again. Rakobi, good evening. May I do mommy why? So that is a question, okay? You can take a screenshot. I'm not going to drop it in a group. I won't do that. Yes, you can use variables and identifiers interchangeably. You can do that. But you need to understand what you are saying. But then if you go and meet someone who doesn't understand identifiers, then you come to the person's level and use variable, okay? Great. And then someone was also asking why bringing f, a small f afterwards, the decimal place. After the decimal, 97.6. Yes, I think you are learning ahead, right? Do you know what the f does? Please, should we accept input for the breadth and length? If you want to go the extra mile and do that, that is fine. But just stay simple. That is why create a simple C++ program. We've not touched on inputs yet, but if you want to do that, that is fine. Are the questions up to you? So can you please scroll up so I can ask a question? Okay, please, with the boolean values true and false, after you compile and run, would the output be 1 or 0? Yes. So if you create a variable, let's say a boolean variable, say bool, then you say maybe status, and you say true. When you print status, you are going to get 1 because you set it to true. If you set it to false, you print the status, you are going to get 0. Okay, so you are still attaching what? F to the decimal. This basically tells the system that it should make sure it treats the number as what a floating point. That is basically what the F means here. Okay. Agbeku, let's listen to your question.
Sir, I want to ask if you are still going to get the same printout if you only write C out less than student ID and you end with a NL with a semicolon.
Is it like so?
Hello, sir. Um, no, no, with the NL. Um, NL. Yeah,
Like
yeah,
so?
sir. Yes, please.
It will only print this thing without this.
Sir, with that.
But that is what I did, or this is what I did.
So, sir, it means when you remove the student ID, you are not going to get the value.
Yes.
Thank you.
All right. Time is not on our side, and I didn't receive the assignment early because, according to Hello, most of you didn't submit the assignments on time, so he couldn't forward them to me, and I don't have them at my disposal, so I wouldn't know how to touch on them. So probably what we can do is we should make sure we show up on time tomorrow, and then we dedicate maybe the first 20 minutes or something to go through. All right. Bright, your question.
Say, I think that the one that asked the question earlier was asking that if you remove the string, the one that is in the quotation marks, then he's asking that will we receive only the one or will he see only student ID? That's what I think
You
he was
only see
asking.
one. You only see one. If you remove the quotation part, you see only one printed. You see only one printed. Yes. So I'm only making sure that I'm making the program more friendly. So you know that okay, this is student ID, this is student age, this is student fee. And I explained this thing. I told you when you want to print a string or a message, you put that message in double quote. But because this student ID here is a variable that we've defined which is holding the value 1, when we want to get the value that is inside of it, we don't have to put this one in double quote. When we do that, it will only print the variable student ID, which is spelled like so. It will print it out just like that without giving us the actual value. Understand that? All right. Okay, so I think there are no more questions. We're going to call it a day and continue hopefully tomorrow. Thank you for showing up. Hello, are you online?
Yes, I'm alright.
Okay, I'm exiting. So.
Alright.